This is the solution to example 11 from notes 2.5. In here, we are given a parent function. So this is the parent function f of x. We're shown its graph. And then we're given some graphs of transformations. And I'll tell you right away that there are no dilations in this first example. So we don't have to worry about stretches and shrinks. So in looking at the graphs, we want to determine how they've been transformed. So in looking at graph A, we can see that we have a reflection in the x-axis, right? Because the graph is pointing downwards instead of upwards. And then if I think about, this is not a parabola, but it's a similar graph. If I think about the vertex, I can see where's my vertex on the transform function. So it used to be at 0, 0, and now it's at -1, 0. So this point is -1 on the graph. So I can see that this graph was actually shifted left 1. And now we're going to do the reverse of what we did in the previous problems where we were given a function and we had to graph it. Now we're going to given a graph and we want to write the equation of the function. So I'm going to write this new graph. I'll call it a of x as a transformation of f of x. So if we take f of x and we reflect it in the x-axis, we'd put a negative out in front. So we'd have negative f, and then if it's shifted left 1, we're going to put f of x plus 1. So we can do this regardless of the function, the equation for the function. Whatever the equation for f of x was, this new function will be reflected in the x-axis because we have the negative here, and it will be shifted left 1. Let's do the same thing for letter B. So here we can see that the graph is not reflected in the x-axis. It's still going up, but the vertex is now 3, -2. So this graph has been shifted right 3 and down 2 relative to the parent function. So let's write the equation for, we'll call it b of x. So b of x is going to be f, and if I want to go right 3, I replace x with x minus 3, and down 2, I'll put a -2 outside the function, and this is the equation for b of x.